Hi, my name is Amelia Renault, and this is my learning log for Math 3050. On the inside, I have my title page and my learning log rules. On my first three pages, I have my table of contents. On my first page, I have my basic vocabulary, which includes our undefined terms, which are point, line, and plane. This is a foldable I made that has point, line, and plane with an example of each and the definition. I love a line because it can be used as many things, including examples such as array, and it extends in both directions infinitely. Types of points and lines are all defined here. I made this little sticky notes that have each of the types of points and the lines under each to help me memorize for exams. One example for this is a half line, which has no endpoint and it extends in one direction. It's not infinite. Therefore, it has an open circle, unlike the array that has a closed circle, because it is infinite on one side. These are angles and all the different types of angles. I made this foldable with the 5 different types of angles. My favorite is the acute angle because it is the smallest angle and it's less than 90 degrees. And here's an image of it right there. Parallel lines cut by transversal. I did these sticky notes that have each of the different types as vertical, interior, alternate interior, are just some examples. And under each angle image, I have a definition. So this is a corresponding angle because each of the angles are equal. This is simple closed curves, and this has two foldables on here. I inserted from our activity book this image, which has all of the different types of simple closed curve and polygonal examples. I made this for me as like a little help for me to be able to identify what kind of curve this is, which it is a closed curve, simple closed curve, polygon, and a concave. Then I made this one as well, and then if I fold it on this side, I can see that it is only a simple curve. This helps me study for exams by trying to figure out what it is, which helps me understand it better. This has both the Jordan curve and the triangle sum conjecture on this page. This just gives me a basic small example of what a Jordan curve is. And if you count from outside the line to the other outside of the line, it'll be even, as well as inside of the line to another area inside the line. It'll also be even in the Jordan curve. For the triangle sum conjecture, it basically states, I have an image over here, that if you tear off each of the 3 edges of a triangle like this, it will make a straight line which is equal to 180 degrees. Therefore, the interior of a triangle is 180 degrees. This is the polygon sum conjecture, which also has regular polygons on here. I inserted my chart with all different shapes all the way up to an engon. It says the number of sides of each, also has a number of triangles, and the total degrees of the interior angles. You can find the degree of the interior angles by multiplying the number of triangles times 180 degrees. Next we have tessellations. This just has a couple of examples on here, such as a hexagon, which is also seen here with triangles to give us a semi-regular tessellation. A semi-regular tessellation is basically, it has multiple different regular polygons, and it goes across the entire plane, which is shown here. quadrilaterals. There are 7 different quadrilaterals. I inserted this graph also from our activity book, and this just shows each type of quadrilateral that there is. My personal favorite is the square because it can also be a rectangle. Next we have space figures, which are basically 3D figures. There are several different types of space figures. One I like is a prism. It's easily identified because the bases give the description, such as this base is a triangle, so therefore it's a triangular prism. And I have this foldable, which has all the different types of 3D space figures that there is. Next, I have the platonic solids. I also inserted this from our activity book to help me remember by having images. My favorite of this one is the chart that we have. This is so easy for me to be able to remember, and as well as the formula, because it helps me better visualize these pictures. And this is easy to find by, for example, a cube. 8 plus 6, which is the vertex plus the faces, gives us 12 plus 2. So it gives us 14. And that's how we are able to find the edges, is by adding this and then adding 2 to that. It gives us the edges. Next we have nets. I inserted this from our Edpuzzle videos to help me remember all the different types of nets we have. I feel like this is one of the more difficult types that we have, just simply because it's hard for me to visualize. So by me putting these in here from our Edpuzzle videos and screenshotting them, this helps me memorize them and remember them and practice over and over and over again the different types we have. For example, this one I like a square pyramid because I can look at the bottom and see that it's a square. That way I know it's the first word to be identified. And then by adding all these triangles together, it gives us a pyramid shape, which helps me better visualize the net. Next we have geometric transformations, which these I find fairly easy to do. I have all the 3 different examples here of different kinds, and I have the answers underneath. My favorite are the reflections, because it's just like a mirror image, and that's very easy for me to be able to understand as compared to a rotation, which is harder for me to visualize. Next we have dilations, which is similar to a translation in my opinion. Basically you take a small triangle and then you multiply it by whatever number. This one, for example, is 2. You multiply each of the numbers. Like this one is 1 centimeter width from the original point. You multiply that by 2 and you get your next point. Next we have symmetries. This is the last entry I have in my learning log for the first 6 weeks. This is basically starts off with talking about line symmetries. For example, I have a butterfly. It has 1 line of symmetry. If I tried to go across, notice the antennas would not be on the bottom. Therefore, it can only have the 1 line of symmetry. This also shows rotational symmetries, which I have here. These are from our activity book as well. For example, we have a rhombus here. If I rotated it 90 degrees, it would not be the same image. But if I rotated it 180 degrees, it would give me the same exact image. Therefore, a rhombus has rotational symmetry. Thank you.